Training AI models, especially the ones that have to understand images, is an incredibly complex challenge, right? How do you teach them to not just see something, but to actually reason about it correctly and, well, do what we want them to do? Today, we're going to unpack a brand new framework called Rubric-Powered Direct Preference Optimization, or RDPO for short, and it really offers a powerful new blueprint for training smarter, more nuanced AI.
So, here's the game plan. First, we're going to tackle the core problem that RDPO is trying to solve. Then, we'll break down the framework into its two main phases. After that, we'll dig right into the results to see if this thing actually works, and finally, we'll talk about why this all really matters for the future of AI.
Okay, so before we can really appreciate the solution here, we have to get a super clear picture of the problem. Right now, one of the most popular ways we try to align an AI with what we want, well, it's facing some pretty serious challenges, especially when you get into complex visual stuff.
And that popular method is called Direct Preference Optimization, or DPO. The concept behind it is actually pretty simple. You give an AI a prompt, it spits out two different answers, and you just tell it, hey, this one is better and this one is worse. You do that over and over and over again, and the model starts to learn to generate responses that are more like the ones we prefer.
But here's the thing. While DPO is pretty powerful, it has some major blind spots. First, the data is often off policy. Now, think of it like this. It's like trying to teach a new employee using feedback from someone who quit 6 months ago. The context is totally outdated, and it creates this mismatch. Second, a simple thumbs up or thumbs down just isn't very helpful. It doesn't tell the model why an answer was better, which means it completely fails to correct these subtle but really critical errors in reasoning or how it understands an image.
All right, so that's the problem. And this is where the innovation from this new research comes in. To solve these issues, the authors developed a new framework they call Rubric-Powered DPO, or RDPO, and it's designed to bring some much-needed detail and precision to this whole training process.
The core idea, and this is straight from the authors, is built on something called instance-specific rubrics. So what does that mean? It means instead of just a simple good or bad label, every single prompt gets its own detailed checklist-style scoring guide. This rubric breaks down exactly what a perfect answer should have, which allows for a way more granular and precise evaluation.
Okay, this diagram lays out the entire process. And I know it might look a little complex at first, but we can break it down pretty easily into two main phases. The top half is all about preparation. It's about creating this pool of instructions and rubrics. And the bottom half, well, that's the active training loop where the model actually learns. Let's start by breaking down that top section.
So phase 1 is all about model-agnostic seed and rubric collection. The key thing to get here is that this is all done offline, before the main training even kicks off. And because it's model-agnostic, this toolkit of instructions and rubrics they build can actually be reused to train lots of different AI models. Pretty cool.
Let's zoom right in on this prep phase. You can see it flows from left to right. It starts with this big data pool of images and questions. From there, a process called seed mining finds the most valuable examples. Then that's followed by rubric drafting, where they create those scorecards. And the final output is a super high-quality instruction rubric pool, which becomes the essential toolkit for the next phase.
Now, that first step, seed mining, this is actually really clever. To find the most challenging and useful examples for training, they don't just pick them at random. No, they take a whole bunch of different AI models and have them all try to answer the same questions. Then, they specifically look for the cases where the models disagreed. This disagreement is a fantastic signal that the problem is complex or ambiguous or maybe an edge case, exactly the kind of tough stuff you want to use for training.
So once they have these challenging seed questions, they create a rubric for each one. On the right, you can see this incredibly detailed prompt that basically tells a powerful AI to act like an expert evaluator. It's instructed to break down what a perfect answer would look like into essential and additional criteria. The output, which you see on the left, is a structured data file, a super precise checklist for what good looks like, including exactly what to check for and how important each little point is.
Okay, let's move on to the second phase, on-policy data curation and optimization. Now that we have our high-quality instruction and rubric pool all ready to go, we can use it to actively fine-tune our target AI model. This is really where the training magic happens.
So looking at the bottom half of our diagram here, you can see the live training loop. It starts with sampling, where the base model we're trying to improve generates a bunch of different answers to a prompt from our rubric pool. Then, in this scoring step,
A separate AI acts as a judge and uses our detailed rubric to evaluate every single one of those answers. This scoring then feeds into pair mining, which creates those high-quality chosen and rejected pairs for the final iterative DPO training.
And the scoring itself is incredibly detailed. The AI judge doesn't just give a simple pass or fail. No, it fills out a whole structured evaluation for each criterion. It has to give a reason for its judgment and assign a score. 0 for incorrect, 0.5 for partially correct, and 1 for fully correct. This is just worlds away from a simple thumbs up.
After all that scoring, the system carefully filters the results to create the absolute best training pairs. It's not random at all. It follows these really strict rules to make sure the chosen answer is high quality and the rejected answer is clearly flawed. The whole goal is to find pairs with a big quality gap between them, which maximizes what the model can learn from every single example, all while making sure the training data stays nice and diverse. So we've walked through the entire, pretty complex process of how RDPO works. But the big question is still hanging out there. Does it actually make the AI better? Let's take a look at the results from the paper.
The headline number is a score of 61.01 on a big benchmark. Now, this is a huge deal because a baseline model, which was just prompted to be more concise, only scored a 52.36. The RDPO framework delivered a massive 8.65-point improvement. That's a serious jump.
Now, let's look under the hood a bit at the training process. This graph shows the DPO loss over time. You can just think of this as the model's error rate, so lower is always better. The red line represents the method that's closest to RDPO's on-policy approach. Just look at how it not only reaches the lowest error rate, but it also follows the smoothest, most stable downward curve. That's a sign of a much more effective and efficient learning process.
Okay, and this chart measures reward accuracy, which is basically how good the model gets at predicting which answer a human would prefer. And again, we see the exact same pattern. That red line, representing the RDPO method, just clearly pulls away from all the others, reaching nearly 90% accuracy. This confirms that the model is really, truly learning from that detailed, rubric-based feedback.
And finally, these charts from the researchers' follow-up studies really seal the deal. The chart on the left shows them fine-tuning a key training parameter to find that sweet spot for the best performance. But the bar chart on the right is even more telling. It breaks down the performance gains by different types of tasks. You can see that the RDPO method, shown in blue, delivers significant improvements across the board, especially in really tough areas like analyzing charts and STEM reasoning.
So, we've gone through the problem, the intricate two-phase solution, and the really compelling results. But what's the big picture takeaway here? What does this RDPO framework really teach us about building better AI? So the key takeaway here is this powerful 1-2 punch. To get the absolute best results, especially with complex visual tasks, you need two critical ingredients. First, the training data has to be on policy, meaning it comes from the model you're actually trying to improve. And second, the feedback needs to go way beyond a simple win or loss. It has to be detailed, criterion-level feedback, exactly what these rubrics provide. This all leads to a really fascinating final question. As AI gets more and more complex, maybe the secret to truly aligning it with what we want isn't just about throwing more data at it. Perhaps the real key lies in the quality and the structure of our feedback, in teaching our models not just what the right answer is, but precisely why it's right.